Okay, in this video I'm going to talk about the Lemoine point of a triangle. So the Lemoine point is basically the intersection point of the three symmedians of a triangle. So, and just to recall, so a symmedian is a symmedian. So we denote that BB prime. Is the line that is symmetrical to the median. So BM is the median. So BM is equal to MC. So M is the midpoint. So BM is the median. Then we take the bisector. So these angles are equal. And we reflect the median with respect to the bisectors. So the line, like basically with these two angles equal. So at equal angles from the bisector. The symmedian is the line that is symmetrical to the median with respect to the bisector. So if we have three symmedians, then they intersect at a single point, and this point is called the Lemoine point of this triangle. So BB prime, let's say CC prime and AA prime. So, and this would be the point L. So theorem. So let AA prime BB prime and CC prime be the symmedians of the triangle ABC. Then AA prime, this lines basically BB prime and CC prime intersect at a single point. Intersect at a single point, which is called the Lemoine point of the triangle ABC. Yeah. So basically, let's prove this. So the proof is going to be like basically a combination of two results that I proved in two previous, like some of the two previous videos. So one is in the previous video I proved the property of the symmedians. So and its connection, their connection, and the symmedians, their connection to the tangential triangle. So basically for the triangle ABC, so if we consider the circumcircle of this triangle, and we consider the tangents to the circumcircle at the vertices, and we extend these tangents until their intersection, so these two would intersect somewhere here. So this large triangle is called the tangential triangle of the triangle ABC. And it turns out that these lines connecting the vertices of the original triangle and this tangential triangle, they intersect. They coincide with the symmedians. So, like basically, if we have here, if we denote the tangential triangle as A2 prime, B2 prime, and C2 prime, then this point is exactly the point B prime, like this for the symmedians. So BB prime is this line, B2 prime is exactly the symmedian. So this intersection point with the sides are exactly the these points A prime, B prime, and C prime. So let's write this. So by the theorem proved previously in the previous video, proved previously, so A2 prime, B2 prime, and C2 prime are the symmedians of the triangle ABC. It implies immediately that A prime belongs to A2 prime, B prime belongs to B2 prime, and C belongs to C2 prime. C prime, of course. Yeah, so now we simply observe that in this large triangle, the tangential triangle, these segments A2 prime, B2 prime, and C2 prime, they are the segments connecting the vertices with the tangency points of the incircle with the sides, right? So and these three lines intersect at a single point, but by another theorem that we proved previously, by the theorem let's write by a theorem and here as well. That we proved previously. So for this large triangle A2 prime, B2 prime, C2 prime, the lines A2 prime, B2 prime, C2 prime, so these are lines connecting the vertices with the tangency points of the incircle, because the circumcircle for triangle ABC in this large triangle, it's an incircle. So they intersect at a single point, and this point is called the Gergon point of this large triangle, at a single point, which is the Gergon point of the triangle A2 prime, B2 prime, and C2 prime. And this is, by the way, not difficult to prove. This is simply like we apply the Chevas theorem and like use the fact that the tangents are equal to each other. So like, for example, from A2 prime, so these two segments are equal to each other, A2 prime B and A2 prime C, and for the other three, the other segments are equal as well. So this is not difficult to prove. I'm just not going to repeat it, like there is a separate video about this. So now, but the first statement is that the symmedians pass through these points A2 prime, B2 prime, and C2 prime. So the connection between the symmedians and the tangential triangle, this is a much more difficult statement. So while the second theorem that we use here is easy to prove, the first one is not. It's a much more difficult statement to prove. But so anyway, so they intersect at a single point, which is the Gergon point of this large triangle, and this is basically it. So this, because these lines are exactly the lines, exactly the symmedian. So therefore, the A prime, B prime, and C prime intersect, because simply it's the same lines, intersect at a single point, and that's it. So, and this point is called the Lemoine point of the triangle ABC. And so the Lemoine point of the original triangle coincides with the Gergon point of the tangential triangle. Yeah, so that's it for this video.